Hello everybody. Once again I am here for the another part of this second unit that is called interference and diffraction. And the introductory part we have seen what is meant to be as an interference and how the Newton's rings plays an important role for getting this interference phenomena, and what will be the calculation part as far as the dark ring is going to be concerned or the bright ring is going to be concerned. So today we will see a very small part related with this same Newton's ring is to be there, and how to determine the wavelength by the Newton's ring is to be there. So to get this case, the same experimental setup is to be there, Newton's rings, and if we know that previous things, that how the setup is to be there as far as this sodium light is to be there, as ordinary light is to be there, and in front of it there is a lens through which when the light, ordinary light, is going to be incident on this lens, there will be a beam of light is going to be parallelly emerge out, and there is a beam, there is a glass plate which is at the 45 degree exactly, and when any light is going to rays are going to be incident on the angle of the 45, they will get reflect to be at the 45 angle, and that will be incident on this plano convex lens, and this plano convex lens there is a at the bottom plane glass plate is to be there, and due to that this air flame is going to be produced at this stage, and due to that the reflected rays having the path differences, and due to that the interference pattern is going to be formed, and you will see the bright and the dark fringes are to be there. So this is what the case we have already learned in this previous session, that how the Newton's rings are going to be formed and how to get the radius in that case for the dark ring is to be there, and what are the conditions for the dark ring and the bright rings are to be there. So the same experimental setup and the same Newton's ring will be produced, and using this we want to find out what is exactly the wavelength of that incident wave is light is to be there. And to calculate this, all this is to be same setup it is discussed previously, what we already explained at this moment is to be there. And now we are looking for considering the one diameter for the dark ring is to be there, and that is dn it is to be written. There are n number of dark rings are to be there. We have seen that how the fringes are to be there, it looks like this, and in this case we are considering one diameter having the nth ring that is to be taken into account, and it is having the dn. And as we know the relationship between the radius and diameter, that is it is always the twice of this uh, diameter is the twice the radius is to be there, and that's why it is to be there that Rn is to be written by is equal to dn by 2 is to be there. And we know how to calculate the radius in that case in the previous session for the Newton's ring, and that was to be Rn square is equal to n lambda r is to be there. So it is to be there how to we have already calculated this case, how it becomes to be as an Rn square is equal to n lambda r to be there. And here this Rn is going to be replaced with dn by 2 is to be there, and when I am putting this into this relationship, it will become dn by 2 square is equal to n lambda r is to be there. And if we are squaring this, then we will get dn square by 4 is equal to n lambda r is to be there. And if this 4 will go right side, then it will become dn square is equal to 4 n lambda r is to be there. So this will be equation number 1. Now if suppose this is for the calculation for the nth dark ring is to be there, the next successive whatever be the dark ring will be there, it will be definitely increased by 1, and that's why it will become dn plus m is to be there. Actually it is after that dark ring there will be a bright, and then again dark is to be there, but I am talking about the next dark ring is to be there. So next successive will be n plus m is to be there. And if suppose I want to measure the diameter at this case for the dark ring dn d n m is to be there, so in that case it will again to be given diameter and radius relationship is to be there, means for the next successive dark ring, if suppose I want to calculate this relationship, then it will again r n m square is equal to n lambda r. N is not to be there, it is n plus m is to be there. So in that case the dn plus m whole square by 4 is equal to n plus m n lambda r is to be there. So why it is to be there, m next successive ring is to be there, dark ring next successive. So in that case I can write this relationship in this fashion. Again this 4 will go right side and this relation will become dnm n plus m whole square is equal to 4n plus m lambda r is to be there. So this is equation number 2 in that case. So now subtracting 1 from the 2, if you look at this carefully, these two relations are to be there. This one is to be 1 and this one is to be 2. So first one is to be dn square is equal to 4n lambda r, and the second one is to be dn plus m whole square is equal to 4n plus m lambda r is to be there. So subtracting 1 from the 2 म्हणजे या 2 मधून जर मी 1 ला सबट्रॅक्ट करत गेलो तर dn plus m whole square minus dn square is equal to, right side of the second is to be 4 into n plus m into lambda r minus it will be 4n lambda r is to be there. So in this case if we multiply or calculate analyze this particular right side is to be there, then it will become 4n lambda r plus 4m lambda r minus 4n lambda r. So 4n lambda r plus and 4n lambda r will get cancelled and the remaining value will be 4m lambda r. So what will be the final relation? We have the final relation after subtracting 2 from the 1 from the 2. It will having the relationship that is dn plus m whole square minus dn square is equal to 4m lambda r. So in this case again if as we have our title is to calculate the wavelength, and wavelength is nothing but to be represented with lambda, and this lambda is equal to nothing but to be, this will go to this side and it will having the relation lambda is equal to nothing but simply that dn plus m whole square minus dn square divided by 4mr is to be there, where r is nothing but to be radius of curvature in that case. And this is what the simply we can calculate the wavelength of the given source, that sodium light is to be there, can be determined. So this is what the simple way the calculation of the wavelength using this Newton's ring. Again it's time to be at home, stay safe. Thank you.